Let's return to our program of items in a warehouse. We said that the warehouse contains items. And we haven't looked at collections yet, so we haven't created a collection of items. But the idea is that items would be held in the warehouse. And we said that all items have an ID and a name. However, there are different kinds of items. One division we might make is to distinguish software from hardware. We might do that because software has an ISBN and hardware has a serial number. However, they're both items. We can represent that in C# through inheritance. We create our class software, then we put a colon and the class name it derives from, in this case, item. What that says is that all software is a kind of item, or is a item, and that's the is-a relationship. Because we inherit from item, all software automatically has an ID and has a name. We can then add the things that are specialized to software, such as the ISBN. We can do the same thing with our hardware, where hardware derives from item and has its specialized pieces. Now it turns out that our hardware can be further divided into computers and peripherals. And so we see that computer derives from hardware, and peripheral also derives from hardware. Computer and peripheral are kinds of hardware, which makes them kinds of items. And that means that a computer will have a CPU type and disks, but it will also have a serial number because it is a kind of hardware, and it will also have an ID and name because it's an item. I put all these classes into a single file for simplicity and so that we can see them at the same time, but normally I would create one file per class. Let's return to our program. We can take out the previous logic and let's make an instance of a computer. Here we've made an instance of my computer, and with my computer, when I hit the dot, IntelliSense offers me all of the properties of a computer: CPU type, disk, but also ID, name, which it gets from item. The ID and name, although inherited from item, are very much a part of my computer. Notice here we have declared my computer using type var, but the actual type that's being assigned is computer. Because a computer is an item, we can say item my second computer equal new computer. Now that's a slightly confusing syntax, so let's understand it. All computers are items, and therefore we can assign a new computer to an item. But notice we only get the item part of the computer. So if we say my second computer and hit the dot, we get the ID and the name, but we don't get the CPU type and so forth. If all we need is the ID, that may work out very well for us. For example, if we have a collection of items, and we'll be looking at collections soon, we can put computers and peripherals and software in there and retrieve them by ID. Because we know that my second computer is in fact a computer, although we declared it to be an item, we can cast it, change it, back to being the type we know it is. One way to do that would be to create a new object variable, and let's call it my second computer 2 equal my second computer as computer. And as says, take this and treat it as if it were this other class. And we know in this case it is. One of two things will be assigned to my second computer too. If my second computer is a computer, then that will be assigned to my second computer too. In that case, we're able, with my second computer too, to access, for example, the CPU type. And we can assign that to a string. If, on the other hand, it had not been a computer, if we had tried to use the as computer on something that wasn't really a computer, it would have returned null. And we would have assigned null to my second computer too, in which case we would not have been able to access the CPU type. We're going to return to all of this when we deal with collections. Let's take a look at one other aspect, which is methods and method inheritance. And let's give our item a virtual method. A virtual method means I intend for this method to be overridden in the derived classes. That is, I intend for the derived classes to make their own version of this method that is specialized to that class. So I can say public virtual, that's the keyword, and then whatever my return type is, we'll make it void in this case, and then whatever my method name is, let's call it purchase. My parameters, let's not have any to keep it simple, and then the body of my method. In this case, the body will use a console write line as a stand-in for doing the work. Now, when I decide to implement that method in software, I can say to myself, well, I'll just inherit that method and not implement it at all, or I can override it to specialize it for software, and that's true for hardware and that's true for computer. Let's not override it first. Let's just see that it works by going back to program. And here I have my second computer too, and I can call purchase on that. And when we run this application, it says purchasing. Well, there's no name. So let's give that a name so that it has something to display. Okay, now I've told my second computer too that its name is Jupiter, and we can run that, and it says purchasing Jupiter. Now notice this is a computer. Computer did not have that method, but it inherited it from item. It also has the right to override that or change the way that method works in the computer class. And IntelliSense will help us with that. If we put in the keyword override and hit space, it says which of the methods that this class inherits do you want to override? It turns out all classes ultimately derive from object. An object has three methods that can be overridden: equals, get hash code, and toString. That's where those are coming from. Purchase is coming from the item. Let's override purchase. When we hit enter, Visual Studio creates the method for us, and the first thing it does is it calls the base purchase method. That's going to call up to item and call the purchase method of item. That's just fine with us. We'll let it go ahead and do that, and we'll add a little bit of additional functionality that says my CPU type is, and fills in the CPU type. Now let's go back to our program in program.cs and set the CPU type. We can now call purchase on this computer, and instead of just calling up to the item, it should call the overridden version for computers. Let's run that. Purchasing Jupiter, my CPU type is i7. So notice that because it was a computer and we overrode the purchase method, that overridden method is what was called. Now, if we call purchase on software, notice here we've created a new instance of software, and we have set its ISBN to 1234, and we've called purchase. When we run that, all we get is purchasing blank. It has no name. Let's give it a name, run it. Here's our earlier purchasing the CPU and then purchasing food, but no ISBN. And that's because we have not overridden in the software. We can go back to the software and override the purchasing method. Once again, we say override. There's our purchase method. It's going to call the base method. And know, by the way, that calling the base method is not required. We could take that out and instead put in completely new logic. So now we're not calling the base method anymore. Instead, we're calling our new logic that displays our ID and ISBN. Go back to Program CS. Here's where we want to see, and let's run the application. And first we get the computer, my CPU is 17, and then we get the override on the software. My ID is 0 and my ISBN is 1234. The ID is 0 because we've not initialized the ID for the software, and so it was assigned the default value for an integer of 0. Let's fix that by saying my software.id equal 101. And now we're going to get my ID is 101 and my ISBN is 1234. So you see we can progressively work on this, and each of these classes can override the purchase method. Now, we could have overridden the purchase method in hardware as well, and then again in computer. And depending on how we declare the object, as an item, as hardware, or as computer, will decide which of those overridden methods is called.